Hey guys, this is test 57 game 4. This is the Foundation Awards game. It's what I would consider a matching or assignment game because although the quarters are numbered 1 through 4, there's not really a before-after relationship here. Rather, it's just about things being adjacent. So we're assigning the 5 grants and maybe even 6 grants to one of 4 quarters, keeping in mind adjacency. So we've got the rule that grants are awarded in all 4 areas. That simply means that that all 5 of these have to be used. They tell us that no more than 6 are granted total, so we have 5 things due to the fact that there are 2 M's, which they tell us later, and maybe there will even be a 6th thing, we don't even know. They tell us that we can't have grants in the same quarter or consecutive quarters, so we can't have, for example, W on 2, and we can't have, since W is on 2, W cannot be on 1 or 3, and when we place the other variables, we'll learn the same thing regarding them, that we cannot have, for example, M in both 1 and 2. So they tell us that we have exactly 2 M's, so I wrote down MM here, and then W on 2. So we can actually, this is pretty bare bones initial setup. We could actually make 3 different main diagrams based upon the placement of these 2 M's. We could have M on 1 and 3, we could have M on 2 and 4, or we could have M on 1 and 4. And that will create the 3 main diagrams for this game, encompassing all possibilities. So here they are, M on 1 and 3, M on 2 and 4, or M on 1 and 4. Now, of course, these are the only M's in the game, encompassing all possibilities for regarding M. Now, space number 4, it's got to be one of T, W, or Y because it cannot be M, so I'll just put down, we got T, W, or Y in that 4th space right here. Now, in the second diagram, we've already, used up M and W on 1 and 3, well, on 2, therefore neither M nor W could be on 1 and 3. Therefore, 1 and 3 will have to be occupied by either T or Y. So T slash Y on 1 and T slash Y again on 3, of course. We could have T or Y repeat, perhaps. Actually, we don't know. We don't know what's going to happen with them. I mean, if T was on 1 and Y was on 3, we could have T again on 3 or 4, perhaps. In the bottom diagram, because we have 3 surrounded by W on 2 and M on 4, we're going to have T or Y on 3 there, and of course we're going to have the other one of those guys appearing somewhere as well. So these right here are our 3 different main diagrams for the game. All possibilities fall within one of these 3, but I've only placed 4 or 5 variables in each of these diagrams, so perhaps we'll have something else go again. Now question number 18 is a typical orientation question. We're just taking one rule at a time and applying that rule to all 5 choices looking for violations. So for example, we know that W has to appear on 2 in every single valid scenario. So we'll check for violations there. A is good on that, but B does not have W on 2, so B is gone. C has W on 2, D has W on 2, E has W on 2. So all those choices are okay on that issue. We know that we have to have exactly 2 M's, so let's look for violations of that. A has only 1 M, so A can be eliminated for that reason. C is good on that issue. D has M on 1 and 4. E has M on 1 and 4 as well, so it's okay on that issue. Now we know that we cannot have things appearing multiple times in the same column or consecutively, so let's look for violations there. We see, let's see, choice D has T in both 1 and 2, unacceptable, so D is gone. Next, let's look at E for violations there. Appears okay. We also want to make sure, though, that we have all 4 types of grants awarded. So let's look at C and E for violations there. E has M, W, T, and Y, so we're all good there. But the problem with E is that it has 2 T's, 2 Y's, and 2 M's. That's too many variables. That would be 7 variables rather than only 5 or 6. So for that reason, E is gone, leaving C by elimination for number 18. Next, number 19, what cannot be true? So you could find the 4 things that could be true, eliminate them, and whatever remains will be your answer. Or if you see something that looks good, of course, just pick it and move on. So what cannot be true? Looking at choice A, could we have, M appear alone the 2 places that it goes? That could happen in either the top diagram or the bottom diagram, perhaps. In the bottom one, we could have T on 2 and Y on 3, and then M would be alone on 1 and 4. Works perfectly fine, just as a particular example there, so A is gone for that reason. Looking at B, 2 T's, 1 and 2, and 1 and 4. That could happen, perhaps in even the bottom diagram. Once again, we could have Y on 3 T on 2, T on 4, works perfectly fine, therefore B is gone. Looking at C, two Y's, 1 and 1 and 1 and 3. We could have Y on 1 here, Y on 3 here, and then T on 2 or 4 perhaps, who knows, works perfectly fine, C's gone. Looking at D, two W's and two Y's. That's the very reason that question 18, choice E, was eliminated, because you can't have other things repeating, multiple other things repeating. I mean, you can have M's repeat, and then simply T's repeat, or W's repeat, or Y's repeat, but you cannot have two of T, W, and Y repeating, because that would be too many repeats, considering that we have only 5 or 6 things. So D is impossible, and as such is our answer for number 19. Next, number 20, if we had W and Y appearing in the same quarter of a particular year. So that would mean that we have either W and Y together on 2, or we have W going again on 4, and having Y appear there. So I'm just going to write down WY in a vertical box, and that's happening on 2 or on 4. Now they're asking us could be true except, so 4 of these things could be true, 1 of them cannot be true. So find the 4 that could be true, eliminate them, and whatever remains is your answer, or if you see something that just looks like it doesn't work, pick it and move on. So this WY thing could potentially happen in any of these diagrams. It's very open-ended. It's not really that restrictive limitation. So when they ask us, could M appear on 2? Yeah, this could happen in the middle diagram. We could have Y on 2 and then have, T on 3, for example, and T on 1. That works perfectly fine, so for that reason, A is gone. Next, looking at B, could we have T on 1? Like I just said, we could have T on 1, WY on 3, T again on 3, works fine, so B is gone for that reason. Next, looking at C, T on 2. We could have TW and Y on 2. Not in this diagram, of course. Not in this one either, but in the top one here, we could have TWY on 2, and then one of T or Y again on 4. Works perfectly fine, so C is gone for that reason. Now, like I said, D, W appearing on 4, that could work in perhaps any of these diagrams. We could have W on 4 and then have Y there as well. Wouldn't really pose a problem, so D is gone as well, leaving E by elimination. And the reason that Y on 3 doesn't work is because WY, like I said, is happening on 2 or 4. Wherever it happens, it would be adjacent to Y on 3, violating the rule that you don't have the same grant occurring in consecutive quarters. That's why E doesn't work, and it's our answer for 20. Next, number 21, if we had 2 grants awarded in just one of the 4 quarters. So they're basically saying here that M will be the only thing that repeats. We're only going to have 5 variables being placed on the main diagrams here. So they're asking us what could be true. Could we have 2 Y's? No, of course not, because Y is not repeating. That's why A is gone. Looking at B, neither M nor Y in 1. And that could be true. We could like M and Y both in 1 if we were in the second diagram here and had no repeats. We could have T on 1 and Y on 3, or Y on 1 and T on 3. But they're asking us what could be the case. If we had Y on 3 and T on 1, this diagram works perfectly fine. It complies with the question stem, and we're not having either M or Y on 1. So for that reason, B is our answer to 21. I will go through the rest though. C saying W on 4 doesn't work because we're not going to have W repeat here. So we wouldn't have W on 4, for example, in the top diagram. C is eliminated. Both Y and T on 1. We couldn't have both of them on 1 because we always need one of them going on, 4 or 3 or 3 as well. So we can't have them going on, we can't have, TY on 1, for example, because then we would have Y again on 3, just as one particular case. That's why D doesn't work. And then looking at E, Y on 1 and T on 2. Again, due to the fact that we're not having anything repeat other than M, we're going to always need one of T or Y on 4 or 3 or 3, depending on which diagram we're falling within. So we would need them to repeat if we were to have Y on 1 and T on 2, eliminating E, leaving B for number 21. Next, number 22, general cannot be true question. So we'll find the 4 things that could be true and eliminate, or we'll just see something that jumps out at us and pick it. So could we have 3 grants and a quarter, none of which is medical? So in the top diagram, we could have all 3 of T, W, and Y appearing on 4. That would work perfectly fine. We'd have M's repeating and W's repeating, but that's okay. So for that reason, A is gone. Next, choice B, 2 grants on 1 and 2 grants on 3. We could perhaps have y going on 1 and then t going on 3, and then have w going on 4, or even maybe y going on 4. This doesn't violate anything. We have m's repeating, w's repeating, but y and t are not repeating. Works perfectly fine just as an example, so B can be eliminated. Next, looking at C, 2 grants on 1 and 2 grants on 4. We could take this t from 3, move it over to 4. Still doesn't violate anything, so we know that C could work as well, and that's gone. But looking at D, t on 1 and 4 with nothing else there. If you look at our diagrams here, if we were to put t on 4 and then t on 1 and nothing else there, that would never work in any scenario because you always have either m on 1 or m on 4 in every single valid scenario. So you can never have something else be the only thing going on both 1 and 4. So D is impossible, and is our answer to 22. I will look at E though. W on 2 and 4 and nothing else appearing there. We do not always have M on either 2 or 4. We have M on either 2 or 4 in the second and third diagram, but in the top one, we have M on 1 and 3. So we could have W going on 4, and then T and Y going on 1 and 3 or something like that. It works perfectly fine, so E is gone, leaving D. Finally, number 23, they're asking us what would completely determine this scenario here, leaving no ambiguity at all. So A and B don't look especially appealing because we've had plenty of scenarios in the past where we already had 2 T's or 2 Y's perhaps. Then looking at the other choices, and of course A and B are actually interchangeable, there's no distinction between them at all in the game. So for that reason, A and B are automatically eliminated because you can't have 2 right answers. So if one was limiting to only a particular scenario, so would the other. So for that reason, they're both incorrect and can be eliminated. Then looking at quarters 1, 2, and 3, I think that, 1's an endpoint, so it's less limiting than something happening on 2 and 3 where it would be surrounded on either 2 or 3. What happens there is surrounded on both sides and could potentially restrict things due to the fact that you can't have grants going on consecutive quarters. So I'd start by looking at 2 and 3, especially, over here we have M and W on 2. So what if we were to have 3 grants in the third quarter, the middle diagram would immediately not be relevant, and we'd be left to the top diagram or bottom diagram. So I see choice E being especially limiting because of the fact that it excludes the middle diagram here. So I'm going to start by using that and cross off the middle diagram and play with 3 grants in the third quarter. So if we were to have 3 grants in the third quarter, since W has to be on 2, those 3 would be M, W, M, T, and Y. So M, T, and Y on 3 in this diagram, also M, T, and Y on the bottom diagram. So I'm putting M, T, and Y there. Now we have W on 2, so we're not going to have W going, on 3, of course. Now what happens as a result? Well, over here, we can't have T or Y on 4, therefore W will have to go on 4. And because we've already repeated 2 M's, we have 2 M's, we have W on 2, W on 4, nothing else is repeating, therefore things are fully determined on the top diagram. Now the bottom diagram, of course, just isn't going to work due to the fact that we already have M on 4. We can't have M's going consecutively, and if we're to have 3 things on 3, it's got to be MW and MT and Y due to the fact that W is on 2. Therefore, this diagram is invalid, and we're left with the top one being fully determined. So for that reason, E is our answer to 23. I will go through the others though. So looking at 3 grants in the second quarter. If we had 3 on the second quarter, we already have W there, so it'd be, 2 of M, T, or Y, but we've got to have, M on 1, so in this diagram, for example, it can't be M on 2. We're going to have T and Y there, but the problem is that we already have T or Y on 3, so we'd have repetition, things going consecutively, so bottom diagrams are relevant. In the second one, we could have, Y on 2 or T on 2, and then we have, we have to have one of those things going on either side. I mean, maybe we could pick Y here, then have T1, T3. That actually turns out okay. This diagram works perfectly fine, but there's no reason that we couldn't have switched it around and had T on 2 and then Y's on 1 and 3. So for that reason, having 3 things in the second quarter does not limit us to one particular scenario, and D is gone. Next, looking at C, 3 grants in the first quarter. Well, since W's on 2, those 3 would have to be M, T, and Y, so I'll just play with the bottom diagram for a minute. But then what's going on 3? Could be T, could be Y. We don't know which one. It's ambiguous. So for that reason, C's gone as well, leaving E for number 23.